In this lesson, we're going to take an introduction to functions. By the end of the lesson, you will be able to investigate and analyze functions and their characteristics, including determining whether a relation is a function. Let's first talk about what a relation is. A relation is any pairing of a set of inputs with a set of outputs. A function is a pairing of a member of inputs with exactly one, and that's the key here, exactly one member of the outputs. A function is a special type of relation in which that happens. The domain is the set of all x values of a function. That's our input. The domain is the set of all x values of a function, also known as the input, independent variable, or the cause. So you'll notice you see domain here, domain. So the domain is the x values of the function, all the possible x values that could be in our function. Our range is the set of all y values in the function, also called the output, dependent variable, or the effect. So you'll notice up here, output, here's my range, here's my range, the set of all the y values that could be in a function. We can determine if a relation is a function by looking at a mapping diagram, set of ordered pairs, table, and a graph. So let's take a look first at a mapping diagram. So if you notice a mapping, we have this left side and this right side and arrows connecting them in between. My left side are my x values or my domain. My right side is the set of my y values or my range. And notice that I have arrows connecting them. That's that input and output. I input an x and my y is my output. What I'm looking for here, if we're determining if it is a function or not, is this a function? I want to look at for my mapping to see if I have any arrows, if I have two arrows coming from any one of my x values. And notice here how each number only has one arrow coming from it. So in this case, yes, it is a function. Let's look at that same situation, but in ordered pairs. So when I take my mapping and I put it into ordered pairs, I follow those arrows from input to output, from domain to range. So I'm going to open my parentheses for my coordinates. So I'm going to go from 3 to -2. Next, I look at my 0, follow my arrow to 0. Next, I have 6. I'm going to follow my 6 to 5. My x is 6. My y is 5. Next, I have 8. 8 also goes to 5. My x is 8. My y is 5. And lastly, -1 comes all the way up here to 4. So I have -1, 4. Now here, when I want to determine if it's a function or not, again, we ask ourselves, is this a function? We ask ourselves, is this a function? Well, I want to look at the ones in purple. I want to look at all of my values in purple here and see if any of them repeat. None of mine repeat. I have a 3, a 0, a 6, an 8, and -1. None of them repeat. So again, yes, this is a function. Now let's take our mapping and make it into a table. So you'll notice here when I made it into my table, I wrote my x values from lowest to highest. I rearranged them from lowest to highest. And now I'm going to do the same thing. Remember that my x is my domain and my y is my range. So I'm going to go from -1, follow my arrow up to 4, 0, follow my arrow down to 0, 3, follow my arrow to -2, 6, follow my arrow to 5, and 8, again, follow my arrow to 5. I'm going to ask, is it a function? Again, we look to see if any of my x values repeat. I don't see any repeating. So yes, it is a function as a table. Lastly, we're going to take a look at a few graphs. You'll notice that these are the same points that we've been looking at, except now I've plotted them on my graph. So notice the point -1, 4. If I start at my center, I go to the left 1 because it's negative, and up 4, 1, 2, 3, 4 because my y is positive. I plotted that point. My next point, I have 0, 0, 3, -2 to the right 3, 1, 2, 3, down 2, 6, 5, 1, 2, 3, 4, 5, 6, up to 5, and lastly 8, 5. I went over 8 and up 5 because they're both positive. So now to determine if it's a function on a graph, I want to use my vertical line test. So what I'm going to do is draw a vertical line. Remember, a vertical line is up and down. I want to draw a vertical line through all of my points. Now, what I'm looking for here when I'm asking, is it a function? When I use my vertical line test is how many points did I hit when I drew my vertical line? Each time I drew my line, I only hit 1 point. So this passes the vertical line test because it only hit 1 point. So yes, that is a function. Last, we're going to look at what happens when we don't have individual points. We have more of a connected graph here. So I'm going to again use my vertical line test. And it will be a function if I only hit 1 point when I draw my vertical line. Now for this one, it's not as clear where I can draw it. I can draw my vertical line anywhere I want to. You can see I can draw multiple. If anywhere I draw a vertical line, I only hit 1 point. If I'm asked, is it a function? I've only hit 1 point when I draw my vertical lines. So yes, it is a function. We've reached the end of this video. We will finish these examples and look at what happens if it's not a function when we return to class. Please come prepared with your notes completed and any questions you may have.